They bind to receptors on the cell surface, flip a few switches, tell those genes what to do, and bam, you got a specialized cell.
So like one growth factor will say, hey, you're going to be a neuron, and another one will be like, time to make some bone.
Exactly.
You
It's
know,
incredible, right? And in the research, there are some amazing examples of this in action. There's this one growth factor, bfgf. It's known to really get nerve cells growing.
okay, and what happens? What did they see when they used this BFGF?
They exposed those DPSCs to it, and those cells, they started churning out all the proteins, the genes that you'd normally find in neurons. Way more of them. It's like they flipped a switch.
Wow, that's amazing. But how do researchers even know which growth factors are the right ones to use? Is it a lot of trial and error?
I'm sure there's some of that, definitely. But honestly, scientists are getting crazy good at deciphering this whole cell language.
That's wild. What do you mean by that?
So they look at the signals that these cells naturally get exposed to during development, like way back in the womb, and then they try to recreate those exact conditions in the lab.
So it's like recreating the environment, the signals that tell that stem cell what to become.
Exactly, like fine-tuning a recipe, but for cells.
That's incredible. Cracking the code of life.